This is Mrs. O'Neill for Chapter 2, Section 4, Chemical Reactions. In this section, you're going to describe what happens during a chemical change, identify 4 possible clues that a chemical change has taken place, and apply the law of conservation of mass to chemical reactions. So iron is an element with many desirable properties. It is abundant. Ooh, there's that word abundant again. That means there's a lot of iron. So it's good that it has desirable properties. It's easy to shape when heated and relatively strong, especially when mixed with carbon in steel. Iron has one main disadvantage. Over time, objects made of iron will rust if they are exposed to air. The brittle layer of rust that forms on the surface of the object flakes off, exposing more iron to the air. In this section, you will learn to recognize chemical changes and to distinguish them from physical changes. Okay, so let's look at some of this information. Some physical changes they talked about are physical property would be shape, so it can easily be shaped, and it's mixed with carbon and steel, meaning it's making an alloy or a homogeneous mixture. So a little bit of iron with carbon makes a really strong substance known as steel. But now let's think about that chemical change they're talking about. Well, when it's exposed to air, that means it's going to react with the oxygen in the air, forming rust. So if we think about this reaction, iron with the oxygen from the air, you're going to make what's called rust. Oh, well, look at that. Iron, oxygen are totally different words than rust, or in future we're going to know how to name this as iron 3 oxide. So again, some elements, this is an element because it's one capital letter and it's on the periodic table. So iron is an element. We have oxygen, which is a diatomic molecule. Again, I know it's an element because it has one capital letter, but it's a diatomic molecule because of this too. And now we have a compound. How do I know we have a compound? Well, we have 2 capital letters and they are combined chemically. This is again also called a combination reaction. We're taking 2 elements and we're two multiple things here, and we are combining it to make one compound or one thing on the right side. So multiple reactants forming one product. So again, read as you write, pause, fill in the blanks, and then play to hear my words. So a chemical property is the ability of a substance to undergo a change. So again, there is a difference between properties and changes. Property is the ability to rust. The chemical change would be iron rusts, or iron did rust. The ability to react with oxygen. So again, the ability for iron to react with oxygen is the property of iron. But if we go back to that equation, if we look at this reaction, we can say, okay, this is actually a chemical change because the iron did rust. So that's where there is a little bit of difference between the wording of a chemical property and a chemical change, just like physical property and physical change. So again, as a chemical change, the composition is always going to change. So examples, again, and I'm going to go through them a little bit more in detail in this PowerPoint. So again, if we burn paper, we started with paper, we do not end with paper, we end with ashes. So again, something to think about, that the naming is going to be different. So the substance that we start with, the reactant, is going to be totally different than the substances that we end with. And again, a lot of times I interact or interuse, that's I guess an O'Neill word, I use a chemical change the same as a chemical reaction. They mean the same thing. So if we take this example, we have a magnet that's going to separate the iron from sulfur. That's just a physical change because the iron, we're taking away the iron from the sulfur mixture, let's say, and we're using a magnet. So we didn't change the iron, it still stayed iron, it just now attracted to the magnet and is taken away from the sulfur. However, if we add some heat, if the mixture of iron and sulfur together would be heated, the iron and the sulfur will react to form what's called iron sulfide. So now we have a totally different substance. So we've taken 2 elements. How do I know this is an element? One capital letter on the periodic table. How do I know this is an element? Sulfur. one capital letter, and it's on the periodic table. So they're going to make what's called iron sulfide. Technically iron 2 sulfide, but again, we'll get into that later. And how do I know I made a compound? Well, I have two capital letters. The other thing to think about is iron and sulfur are totally different words than the iron 2 sulfide that we made. So why is this a chemical change? In other words, what do you see that would say, oh, this is totally different? Well, one thing you do notice, hopefully, is that color. So we had this silver and we had this yellow substance. Now we have this like glowing pink stuff in here, whatever it might be, and maybe when it cools off it's going to turn like a whitish color or stay this pinkish color, but the color changed. We also can see that light was given off as we heated it. The other thing, and this is why we don't do this in lab anymore, because I used to stink up the place. Oh my goodness, when these two things combined it and we heated them up, it used to make the whole room smell and down the hallway, so it smells like rotten eggs. So that's going to be another evidence that a chemical change has taken place. So here again we have iron and the sulfur. Oh, I forgot to add my little sulfur there. Those are our reactants. We'll add some heat and we're going to form some products. Okay, so here are some evidences of a chemical change. This is what's really important. Most of you probably I could give you a whole list of stuff and you could tell me if it's a physical change or a chemical change. But the above and beyond, or the chemistry part of it, is the why, the evidence. What's going on to cause that chemical? What do you see? What do you smell? We're going to be using our senses to decipher what evidence there was to make that a chemical change, to really know that it's a chemical change. Well, there could be a transfer of energy. And energy could be in the heat or light, in the form of heat or light. Now, temperature could also be in the form of temperature, and that means that it could go up or down. Most of you can tell me that if you cause something on fire, the temperature increased, and that's a chemical reaction. But how about something like your cold packs for those athletes out there, or if you get injured somewhere and you don't have ice available, the trainer might break something apart, shake it up a little bit, and give you an ice pack. For those of you who may go hunting or skiing, you might use those. I'm sorry, that would have been a cold pack for the athletes, or a hot pack for when you go to places when it's cold. Okay, same thing. They're at room temperature. You break them or shake them, and there's causing a reaction. Now, I highlighted change in color because this one's a little tricky, because it can also be a physical change. So we'll talk about this more in detail when we get to our labs and some examples. But color change, just like you saw with the iron that was regularly silver color and now turned to rust, which is more of that rusty brownish color, right? There was a color change. However, how about if you want to change the color of your walls? I want to change the color of my walls from bright green to magenta. Well, the wall is still a wall. All I did was change the color. So we do have to be careful with color change because that could be chemical or physical. If we produced gas, how do we know we produced gas? Because we either see some bubbles, or we see some smoke, or again, we smell some of that odor. And if there's a form of a precipitate, and again, we'll talk about this and we'll see this in lab, where we take two things and we mix them together, two liquids, mix them together, and now we have like a chunky solid. Sometimes it just looks like a big cloud has formed. So by all means as well, when I'm talking, there's plenty of room in the margins to add any extra notes that you want. So here are some other examples. Bubbles of carbon dioxide here in A form when the geologist puts acid on a rock that contains compounds called carbonates. In picture B here, when a test tube stripped is in urine, the color change is used to estimate the level of that sugar glucose in urine, again, to test for something like diabetes. And here, one step in the production of cheese is a reaction that causes milk to separate into solid curds and what's called liquid whey. So what's the law of conservation of mass? Well, mass is neither created nor destroyed. And I will always say this is really the law of conservation of mass, matter and energy, because mass, matter, or energy cannot be created or destroyed in a chemical reaction. And this has been done over and over. It's a law, so it is 100% true. So here's an example. If we take 5 grams of hydrogen and 5 grams of oxygen, how many grams of water would we form? No, hopefully you can figure that one out pretty quickly. So let's look in a little bit more detail. We have a log, we have some fire. If we add the kilograms together, we get 31. Well, we're going to produce ashes and smoke. Well, the ashes now are going to be 28 grams. Not 30 anymore, but all the smoke that was released was 3 kilograms. So together, that still equals 31 kilograms. So again, something to think about here, a chemical change, the name of the products are going to be different than the name of the reactants that you started with. So here we have log and fire as our reactants, and our products are ashes and smoke. Now again, those are just general terms, but we could say that this would be wood, whatever would be made of. Really, oxygen is the fire, ashes would be the carbon, and smoke is going to be H2O and carbon dioxide. So again, this is just a general way of saying your befores and your afters are different, but the conservation of mass will always be there. So how about these two liquids? When they are mixed, they react. Now, big issue here though, right? None of the products are gases. So let's say we take these two little vials, we take our reactants, we form our products. Again, there's no gases, so no gases escaped. The question is, first of all, how do you know the reaction took place? Well, what do you see? Use your senses. You saw that there was a color change. And then again, how do you know that the mass is conserved? Well, if I look here, I started with 43.43 grams and I ended with 43.43 grams. And again, hopefully we'll get a chance to do this in lab as well. So are you ready for that quiz? Here we go. So pause, read, see if you can come up with the correct answer. Hopefully that makes sense. And again, if it doesn't, this is when you need to come see me in class, write it down in your notes. You got plenty of room in the margins. Number 2. Hopefully that makes sense. Remember, a change of state just means that you're changing the state of matter or the phase. In other words, going from solid, liquid to gas or vice versa. And number 3. Hopefully that makes sense. All right, we'll see you in class.